Welcome back to part 4 of our basic derivative rules. Just a reminder of that power rule and the two steps that we have. We start with x to a power. Then when we do its derivative, the pattern that we found out by using that difference quotient and that limit stuff going on is that we will bring down the power out in front as multiplication, and then we'll subtract 1 from the power. So we're looking at basically two steps for our power rule. And so let's finish off some of those expressions that we had from the previous part. And this time I'm looking at 2x to the 6th divided by 3 square root of x. Now remember, before we actually do the derivative, we want to do the rewrite. We want to convert it into combine our x's together and get a single power. And so that's what we're working here, and we did this previously. So we're looking at the expression of 2/3 x to the 11/2. So that's what we want to do the derivative. And the power rule says let's bring that 11/2 down in front as multiplication. And so then we would, so we got the 11/2 out in front as multiplication. It's going to multiply the 2/3. And then we're subtracting 1 from the power, so we're getting 9/2. So 11/2 minus 1, 11/2 minus 2 over 2, the 2/2, and that's where I'm getting the 9/2. And then the next thing is just kind of cleaning up this expression. And so working the coefficients, as you can see, the 2's will divide out, leaving us a nice 11/3. 9/2, 9/2 is another way of saying 4.5. And so I've got x to the 4th and a square root of x. That's x to the 4th and a half kind of idea for the powers. And so that's just another way of writing your final answer. Another expression that we had was 3 radical x times the quantity of that square root of x minus 1 over the 6th root of x. And so once again, we rewrite that. We clean it up a little bit. Because of the minus sign there, that subtraction, we're going to end up with 2 separate terms, which is fine. And that's what we're playing with. So now we wanted to do the derivative of each term separately. So we're going to do it one at a time. So for our first term, we're bringing the 1 out in front as multiplication. So 1 times 3. And that x becomes x to the 1st. That becomes a 0 power because 1 minus 1 is 0. And then for the second term, forget about what we just did. Now we're looking at the second term individually. So we're bringing a 2/6 out in front. We're subtracting 1. And 2/6 minus 1 will get us a negative 4/6. And so that's what we've done with the power rule, those 2 steps. And then when we clean this up, x to the 0 is 1, so we're going to end up with a nice 3 out in front here. 3 times 2/6 is going to reduce really nicely for us. It's going to multiply to 1. Oh, I have a typo here. This plus sign should be a minus sign. And then the negative 4/6 power should make us a nice 6th root with x to the 4th. And again, I apologize. This should be a minus sign here. That's subtraction. Okay, so I want to now finish off and do some extra step for you, and that's actually doing some evaluation. That's doing the derivative and then evaluating with the number. So what I've got here in this notation over here, this dy over dx, have a vertical line here with x equals 2. Basically, this is a combination. It's saying take the derivative of that thing that we called y, that formula that we're calling y. When we get the derivative, plug in 2 for the x value and calculate. So that's what that notation is basically saying. Dy over dx, do the derivative, and then the vertical line with that x equals negative 2, plug in 2 and evaluate. And then over here on the right-hand side, we're seeing the f prime 4, 4 is in the parentheses. This is basically telling us the same 2 steps. The prime symbol there is telling us to take the derivative, and because the 4 is inside the parentheses, that's our function notation to say, after you take the derivative, plug in 4 and evaluate. Okay, so let's do it then. So for our first expression here, we got y equals 12x to the 11th plus 46. We're going to do the derivative. You're going to notice I bring the 11 down in front, multiplying to the 12. That's bringing down that power. And then subtracting 1 from the power. So that's we went from a power 11 to a power 10. But one thing you may have noticed, what happened to the 46? And you may recall the constant rule, which basically says when doing the derivative of a number, just a single number, has no variable associated with it, the derivative would be 0. So that term goes away. And so now we've got our derivative. Our next step, I just did a little cleaning up here, 11 times 12. And then our next step would be to plug in the 2. So wherever we see an x in that expression, we plug in 2. We go 2 to the 10th times 121, and we're getting our answer of 123,904. So basically, this notation is telling us take the derivative, then plug in 2. For our next one here, we have f of x is equal to 6 square root of x to the third. And we want to find f prime of 4. So what we're doing here is, first step, do your rewrite. And so square root of x to the third is the same thing as x to the 3/2. I need that powers. And so then I'm ready to do the derivative. Bringing the 3/2 out in front, bringing that power, multiplying that 6, and then subtracting 1 from the power, which will give me a power 1/2. And so then we're basically ending up with 9 square root of x, because the 2 will go into the 6, make a 3. 3 times 3 will make our 9. So our derivative, our f prime is 9 square root of x. And so our next thing we want to do is we want to evaluate the derivative at 4. So we're looking for f prime of 4. And when we do that, we plug 4 in, take the square root of 4 is 2. 2 times 9, we get our 18, and that would be our final answer for f prime of 4. So there's our basic rules, introduction to our derivatives using these shortcuts. And our shortcuts are just basically looking at this pattern, looking at it over and over again, and finding out, hey, do I have to do all the algebra? And we found out, no, it's a very consistent pattern. So that power rule works really nice for our polynomials. Thanks, and this is Dr. Pat signing off.